So yesterday we talked about what? Logarithms. Guess what we're going to talk about today? Logarithms. Excellent. Okay. Why would we talk about something for more than one day? Oh, not just because it's super hard? Yeah, in fact, it's not, is it? Okay. So let's remember what we talked about yesterday. Log base 3 of x equals 5. What form is that in? How do you know that's in logarithmic form? It literally says log in it, right? Okay, that's in logarithmic form. How do you rewrite it into exponential form? What's the base here? Then that's the base here. Exponent equals the argument, right? Can you go the other way? What form is that in? Exponential. Can you write it in logarithmic form? What's the base here? Then it's the base here. The answer is the argument equals the exponent, right? Okay. So these are easy to go back and forth because they are equations, right? Okay. Even now right here on this one, I could ask you to solve this, couldn't I? And to solve this one, you could write it in exponential form. Now, do you know what 3 to the 5th is? No, but you could figure it out, right? Even without a calculator, you could figure it out. Just do some multiplication, right? Calculator makes it easier, though, doesn't it? Okay. But that's something we could, solve, right? Well, here's the difference. Today, your problems are going to look more like this. Yeah. Log base 3 of 27. And the directions are evaluate. So, evaluate, what does that mean? Well, just asking what it's the same as, right? It's not going to say solve. This is not an equation, so we can't solve it, but I can tell what this means, right? Log base 3 is also equal to, log base 3 of 27 is also equal to what? Is basically what we're asking. Okay? Well, if I think about this in my head, or write it down, 3 to some power equals 27 would be what it looked like if I rewrote it in exponential form, right? Well, 3 to what power equals 27? Done. What about this one? Log base 8 of 64. If I rewrote that in exponential form, it would be what? 8 to some power equals 64. 8 to what power equals 64? 2. Okay, done. Any trouble with either one of those? Okay. Log base 4 of 4. Four to what power equals 4? 1. Yes? Log base 6 of 1. 6 to the first power equals 1. 6 to the 0 power equals 1. Guys, anytime there's a 1 in the argument, that should be like a heads on moment. Okay? Everybody okay so far? This seems a whole lot like what we did yesterday. And your answer is? Yeah, it is. Okay. So what about this? Log base 2, of 0.5. Well, it might be a little easier to see how to do this if I rewrote this problem. What if I rewrote this problem to be like this? Log base 2 of 1/2. What if this just said log base 2 of 2? What would the answer be? 1, because 2 to the first power is 1, right? Except the 2 is in the denominator, not in the numerator. Is there anything that we know about that moves stuff from the numerator to the denominator as far as exponents go? Yeah, negative exponents, right? So you just told me 2 to the first power is 2. So 2 to what power equals 1 over 2? Yeah, perfect. So what about this one? Log base 3 of 1 over 243. You know that one off the top of your head, right? Yeah. I even hinted at it earlier, didn't I? Yeah. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. Hopefully you can see that 81 times 3 is 243, yes? So what's the answer here? Negative 5, because 2 to the fifth power is 243. So to make it 1 over 243, we just get negative 5. Yeah? Now comes the really difficult ones. Well, but they look difficult. Is that fair? Okay. 4 log base 4 of x. 4 raised to the power of log base 4 of x. It's in the log. So it's 4 log base 4 of x. So this is the log and the x are all on the same line. This 4 is just a little bit lower like a subscript. But all of this is a superscript of the 4, right? And it's an exponent of the 4. So earlier what they tried to do is write it in exponential form, right? 4 to some power equals log base 4 of x. Except that doesn't help me at all. So it would be really nice if you knew the little rule about this. There's a rule, yeah. The rule is if the bases are the same, the answer is what's left. Yep, done. 2 log base 2 of 3x. Because if the bases are the same, the answer is what's left. Look at this one. Does the same rule apply? If the bases are the same, is the answer what's left? Yeah, right? Isn't that weird? Yeah, a lot of math is weird. That's fine, because so are we. Real quick, before we do the last example, we need to talk about this. Guys, I know your whole life that people have told you that this is a letter. That's because it is. Okay? But in math, we use this letter to represent a number, a very specific number. Turn your calculator on, please. Oh, excuse me. After you take the cover off, then turn your calculator on. Sorry, we'll get it to you eventually. I know, it's okay. Yep, absolutely. Okay, do you see this E right here? This is not the E I'm talking about. Do you see this pi button right here? Please press it. When you press that pi button, this menu comes up, right? Do you see this fourth one right here? That's the E that I'm talking about. Oh, it's mad. Sorry. Go away. Do you see what the number E represents? 2.71828. And on and on and on. E, if you'll remember from the very beginning of school, we talked about it being an irrational number, and that's because it's a number that cannot be written as a fraction and it doesn't end. Right? What's another example of that? Pi, right? We just talked about that. Yeah? Okay. So what I need you to know about this, yesterday, can we go back to yesterday real quick? On the bottom of our homework, we talked about a common log, right? What is the base of a common log? 10. So I could write log of 2x, and we really know what I mean is log base 10 of 2x, but I don't have to write the 10, do I? Okay? Here's the deal. There's another kind of base, there's another kind of logarithm like this that's a common log. There's another kind that's called a natural log. Natural log. What base does a natural log have? There's not one written, so is it automatically 10? No, that's the base of the common log. Okay? Natural log actually is this. Oh, but we do not write this. Oh, no, no, no. Mathematicians would laugh at us if we did that, because this is ridiculous, right? Isn't it obviously ridiculous? We don't write log base e. What we write instead is natural log, because it seems obvious that it's natural log or something. Maybe it's French. It's like log au naturel or something, right? I know I'm being silly, but do you understand what I'm saying? Log of 2x means log base 10 of 2x. Natural log of 2x really means log base e of 2x. But we don't write this. Yeah? So if I think about these problems that we just did, and I give you another example like this, what's the rule about this? If the logs are the same, the answer is what's left, right? Can I say it again? If the bases are the same, the answer is what's left. Guys, what's the base of this log? E. So are these bases the same? Then what's the answer? X. Does that make sense? There's lots of really weird, like little tricky things with logs. Okay? This is actually a tricky thing with logs. The base is the same, the answer is what's left. This is a tricky thing with logs. Because when there's a 1 in the argument, the answer is 0. It doesn't matter what this base is, does it? Because anything to the 0 power equals 1. Okay? This is another one of those things. If the base are the same, the answer is what's left. Base are the same, answer is what's left. Base are the same, answer is what's left. Got it? So hopefully that doesn't fill you with dread when I say these are the tricky things, because were any of those hard? No, it's just something you have to think about, right? But we mostly have to think every day. I mean, some of us don't, but we good? Any questions about logarithms? Any from yesterday or any from today? Ask me. Yes? So 2 e ln of x. Well, what's this equal? X. And then I still have that. Yep. Okay. Any questions? That was a good question, by the way. Okay. Well, but why isn't this 2 here to multiply? That was the base, right? This 2 is not part of the base. It's the e that's the base. So we kind of ignore that 2 until I can simplify this, and then it comes on. Okay? Any questions about logarithms so far? We good?